They're big, they're hot, and they hold a lot of gravity. So let's cut to the chase. What is a star? A star is a giant sphere of plasma held together by its own gravity. They shine because of thermonuclear fusion, which uses extremely high temperatures to force hydrogen into helium. Most stars are between 1 to 10 billion years old, and there can be up to 400 billion stars in our own Milky Way. So how are stars created? Well, first, they're born in dust clouds, aka nebulas. One of these nebulas is the Orion Nebula. It's south of Orion's belt. You can see it with the naked eye. Disturbances in these dust clouds creates knots, large groups of mass. If they have enough mass, they can collapse upon themselves. This creates a protostar, and the hot core of this protostar will eventually become a star. The remaining dust can be on planets, asteroids, comets, or they can stay as dust. Now, stars require millions of years to mature. Our own sun took about 50 million. Now, it begins to undergo a chain reaction to convert hydrogen to helium. This will continue for about 90% of the rest of its life. However, their lifespan depends on its mass and their consumption of hydrogen. Smaller stars generally burn up less hydrogen, so they live longer. Let's talk about the types of stars. Stars are usually classified under the Morgan-Keenan system, ranging from the hottest O to B, A, F, G, K, and the coolest M. Then they have a number, with 0 being the hottest and 9 being the coolest. Finally, they're assigned a Roman numeral based on the luminosity, with Unus being for a supergiant and Septum being for a white dwarf. Yep, that's how you actually pronounce Roman numerals. Now, let's talk about the majority of stars in the universe. Red dwarfs. They're the smallest and the coolest stars, ranging from about 2500 to 4000 Kelvin. And since the rate of fusion is slower, they can live tens of billions of years. Next are main sequence stars. The red dwarfs I talked about are part of these. They span a wide range of luminosities and colors, and include our own sun. Our sun is classified as G2 Quinque, also known as a yellow dwarf. Finally, the biggest stars are giants, supergiants, and hypergiants. These are the big guys. These stars can be more than 100 times more massive than the sun, and have temperatures of more than 30,000 Kelvin. That's pretty hot. However, they have a pretty short lifespan. So to finish this off, stars are huge, hot, and come in many different shapes and sizes. I hope you found this video interesting and educational. And hey, don't worry, our sun isn't going to blow up for another 10 billion years.